We'll discuss about the answer of part 3, question number 3A. Find the vertical and horizontal asymptotes of the graph of the function y is equal to f of x is equal to 3x plus 5 divided by 6 minus x. First we will find out vertical asymptotes. Vertical asymptotes. Vertical asymptotes. So in order to find out vertical asymptote, so here the function is given to y is equal to 3x plus 5 divided by 6 minus x. So on cross multiplication we are getting that y into 6 minus x is equal to 3x plus 5. So in order to find out the vertical asymptote, first we have to divide the given equation with the highest power of y. Here it is y. So on dividing this equation by y, we are getting that 6 minus x is equal to 3x plus 5 divided by y. So in order to find the vertical asymptote, we have to divide the entire equation with y, and then we will take limit y tends to infinity. So taking limit y tends to infinity, it is 6 minus x minus 3x by y minus 5 by y is equal to 0. So when y tends to infinity, this will tend to 0 and this will tend to 0. So we are getting that 6 minus x is equal to 0. So that implies that x is equal to 6. So it is the horizontal asymptote. It is the vertical asymptote. Now again we will find out the horizontal asymptote. Horizontal asymptote. So similarly, when we will find out the horizontal asymptote, we have to divide with the highest power of x. So what is the highest power of x? Highest power of x is x. So we have to divide this equation with x, so that it will be y by it is the given equation is your 6y minus xy minus 3x minus 5 is equal to 0. Now on dividing this equation by x, we are getting that it is 6y by x minus y minus 3 minus 5 by x is equal to 0. Now taking limit x tends to infinity, so this will tend to 0, this will tend to 0. So we are getting that minus y plus 3 is equal to 0. So that, minus y minus 3 is equal to 0. So y is equal to minus 3. So that is the horizontal asymptote. So horizontal asymptote is y is equal to minus 3. Y is equal to minus 3. Asymptote. Okay. To find the area of the surface generated by revolving the curve y is equal to square root of 4 minus x square, where x is greater than equal to minus 1 less than equal to 1 about the x-axis. So here you see that it represents the curve y is equal to square root of 4 minus x square represents a circle. That is where x varies from minus 1 to plus 1. Minus 2 to plus 2. This point is 2, 0. This point is minus 2, 0. And this is minus 1, 0. Minus 1, 0. This is 1, 0. 1, 0. So we have to revolve. We have to find out the area of the surface which is generated by revolving this curve y is equal to square root of 4 minus x square about the x-axis. About the x-axis. Now here you see that we know that required area that is equal to required surface area, that is equal to x varies from -1 to 1. It is 2 pi y with respect to s, where s is the arc length. So now it is equal to 2 pi, definite integration -1 to 1 y into ds. Now this can be written as ds by dx whole into x, whole into dx. Now where we know that ds by dx, that is equal to square root of 1 plus dy by dx whole square. 1 plus dy by dx whole square. So from here, y is given to be y is equal to square root of 4 minus x square. So from here, what will be the value of dy by dx? The value of dy by dx will be minus x divided by square root of 4 minus x square. So if y is equal to square root of 4 minus x square, then dy by dx is equal to derivative of this thing. It's 1 by 2 into square root of 4 minus x square. Again the derivative of 4 minus x square with respect to x. Minus 2x. 2 can cancel out. So dy by dx is equal to this. Now, so on putting the value of dy by dx whole square, here it will be square root of 1 plus dy by dx whole square is equal to x square divided by 4 minus x square. So it becomes 2 divided by square root of 4 minus x square. It is equal to 4 minus x square plus x square minus x square plus x square cancelled out. So 4 square root is 2. 2 divided by square root of 4 minus x square. So this is the value of ds by dx. So it is equal to 2 pi. Integration varies from -1 to 1 y into dx y. What is the value of y here? Y is equal to your square root of 4 minus x square into dy by ds by dx, that is equal to 2 by square root of 4 minus x square with respect to x. So this will be cancelled out. So now it is equal to 2 pi into 2, that is equal to 4 pi. So 4 pi integration, definite integration, x varies from -1 to 1 dx. So that is equal to 4 pi. And what is the integration of 1 with respect to x? It is equal to x, and limits from -1 to +1. So it is equal to 2 into 4 pi, that is equal to 8 pi. So this is the surface area which is generated by revolving this curve about the x-axis, where x varies from -1 to 1. If we see it, we have to find out, using Leibniz rule, we have to find out third derivative, where y is equal to y into x cube sin x. Now what is, first of all, solution? What is Leibniz rule? So Leibniz theorem, according to Leibniz theorem, nth derivative of product uv with respect to x, that is equal to u subscript nv plus nc1 u subscript n minus 1 v1 plus nc2 u subscript n minus 2 v2 plus nc3 u subscript n minus 3 V3. In this way, the last term is NCN, that in U into Vn. So first term is here, it is similarly it is NC0, but NC0 value is 1 and NCN is 1. So this is the nth derivative of the product UV with respect to x. Now in the given question we have to find out third derivative y3. So let us find out y is equal to, if y is equal to here it is given that y is equal to xq sin x, xq into sin x. So here you see we have to take the function to be u whose nth derivative can be found out. Because if you take u is equal to xq, then its fourth derivative becomes 0. So here you will take sin x to be u and v is equal to your xq. Why? Because here nth derivative of sin x can be found out. Now u is equal to sin x. U is equal to sin x. So what is the value of u subscript n? We know that nth derivative of sin x is equal to sin of n pi by 2 plus x. What is n minus 1th derivative of sin x? It is sin of n minus 1 pi by 2, n minus 1 pi by 2 plus x. Similarly, what is the value of u subscript n minus 2? That is n minus second derivative of u. That is sin of n minus 2 whole into pi by 2 plus x. Similarly, u subscript n minus 3. Again, here we will find out v is equal to your xq. V is equal to xq. What about your v subscript 1 first derivative? It is equal to 3x square. V2 that is equal to 6x and V3 is equal to 6 and V4 onwards it will be 0. So here we will find out u subscript n minus 3. N minus third derivative of this u sin x is how much? It is equal to sin of n minus 3 into pi by 2 plus x. So nth derivative of uv, that means here nth derivative of xq sin x, nth derivative of xq sin x with respect to x, according to Leibniz theorem, it will be equal to NC0 un v. Un, what is un? Nth derivative of sin of n, nth derivative of sin x, that value is equal to sin of n pi by 2, sin of n pi by 2 plus x into v. V is equal to your xq into xq plus next term is NC1. Next term is NC1. U subscript n minus 1, its value is equal to sin of n minus 1 pi by 2, n minus 1 pi by 2 plus x into V1. What is V1? V1 is equal to your 3x square into 3x square plus next term is NC2. Next term is NC2 sin of n minus 2 into pi by 2 plus x whole into V2. V2 value is your 6x. So next term is your NC3 sin of n minus 3 into pi by 2 plus x into V3 is equal to 6. And onwards it will be 0. Onwards it will be 0. Why 0? Because V4 is equal to 0. So V4 0 means V5 also 0. So onwards it will be 0. So we will take up to this term. Next onwards it will be 0. Now, putting n is equal to 3. Putting n is equal to 3. Putting n is equal to 3 in the above equation. In the above equation, it will be third derivative of x cube sin x with respect to x, that is equal to your 3c0, n is equal to put 3, 3c0 is 1, sine of 3 pi by 2 plus x, sine of 3 pi by 2 plus x lies in the fourth quadrant, so it will be minus cos x into x cube plus 3c1, putting n is equal to 3, we are getting 3c1 is equal to 3, sine of 3 minus 1 2, that becomes sine of pi plus x, sine of pi plus x means it is lying in the third quadrant, so where sine is negative, so it is minus sine x, into 3x square plus 3c2 again it is equal to 3, sine of 3 minus 2, 3 that is 1, so sine of 90 plus x, that is equal to cos x, into 6x. Next term is plus nc 3c3 value is 1, so it becomes, putting n is equal to 3, it becomes 0, so sin x into 6, so it is 6 sin x. Now on further simplifying, we are getting how much? We are getting minus x cube into cos x minus 9x square sin x into cos x, sin 9 minus 9 x square sin x plus 18x cos x plus 6 sin x. So it is the third derivative of x cube sin x. It is your answer. This is the answer. Okay. In here 3D, we have to evaluate limit x tends to infinity x divided by 1 plus x whole to the power x. So how to find out the limit of this thing? So first of all, here you see that when x tends to infinity, x by 1 plus x, it tends to 1. And when x tends to infinity, this will tend to, so it is, the limit is of the form 1 to the power infinity form. So first we take that, let y is equal to x divided by 1 plus x whole to the power x. Now taking log on both sides, it is log y is equal to log of x divided by 1 plus x whole to the power x, and that becomes x log of x divided by 1 plus x, and this can be written as x into log of 1 plus x by x whole to the power minus 1. So that is equal to minus x log of 1 plus 1 by x. 1 plus 1 by x. So it is the value of log y. Now, therefore, taking limit x tends to infinity on both sides, we are getting that limit x tends to infinity log y is equal to limit x tends to infinity. It is minus x log of 1 plus 1 by x. 1 plus 1 by x. Now, this can be written again, this can be written as, so minus, take it out, minus is constant, so we can say that it is equal to limit minus or here I can write it minus limit x tends to infinity, limit x tends to infinity, it is log of 1 plus 1 by x whole divided by 1 by x, whole divided by 1 by x. Now here you see that when x tends to infinity, 1 by x tends to 0 and log of 1, that is equal to 0. And when x tends to infinity, 1 by x also tends to infinity. So the given limit is of the form 0 by 0 form. Now we can apply L'Hospital's rule. So by L'Hospital's rule, by L'Hospital's rule, by L'Hospital's rule, we get that minus limit x tends to infinity. What is the derivative of this thing? Log of 1 plus 1 by x, its derivative is 1 by 1 plus 1 by x. Again the derivative of 1 plus 1 by x, that is equal to minus 1 by x square divided by derivative of 1 by x, that is also equal to minus 1 by x square. So when x tends to infinity, that means x is not equal to infinity, so 1 minus 1 by x square can be cancelled out. Now we are taking limit, it is minus limit when x tends to infinity, 1 by x tends to 0, so it is 1 by 1 plus 0, that is equal to 1. So we are getting that limit, x tends to infinity. We are getting that limit x tends to infinity log y tends to minus 1. Now, so since it tends to limit x tends to infinity log y tends to minus 1, now we can take that limit x tends to infinity, it is e to the power log y will tend to e to the power minus 1. And we know that limit x tends to infinity, e to the power log y is y, y tends to e to the power minus 1. Now this implies that x tends to infinity, y value is how much? Y is equal to x divided by 1 plus x whole to the power x. So it will tend to e to the power minus 1. That is the answer. Thank you. Question number 3E. Use reduction formula to evaluate integration dx by x square plus a square whole to the power n. So here we will find out the reduction formula for this integral. Now let I subscript n is equal to integration dx divided by x square plus a square whole to the power n. So we can write this thing as integration of 1 into 1 by x square plus a square whole to the power n with respect to x. Now we take this as first function and this as second function. 1 is our second function. Since we know the integration of 1 with respect to x is x, so that's why we take this as the second function, and first function is 1 by x square plus a square whole to the power n. Now integrating by parts. Now integrating by parts. Integrating by parts, we get that I subscript n, that is equal to first function means it is 1 by x square plus a square whole to the power n into integration of 1, that is equal to x minus whole integration derivative of first function, that means derivative of 1 by x square plus a square whole to the power n, that is equal to minus n into x square plus a square whole to the power minus n minus 1 into again the derivative of x square plus a square, which is equal to 2x. So into integration of second function, one integration is equal to x whole with respect to x. Now here you see that it is x divided by x square plus a square, x square plus a square whole to the power n, minus into minus it will be plus. So 2n taking common, it is x into x, that is equal to x square divided by x square plus a square, x square plus a square whole to the power n plus 1 with respect to x. Now here you see how can you reduce this thing in terms of in. So here we will add a square and we'll subtract 1 square. So it is a plus a square minus a square, that means it is cancelled out, it is as it is 2x square divided by this thing. Now this integration is how much? It is equal to, so in. On the left hand side it is in here. So in is equal to x by x square plus a square whole to the power n plus 2n integration of x square plus a square by this thing, it is equal to 1 by x square plus a square whole to the power n plus n with respect to x minus a square integration of dx divided by x square plus a square whole to the power n plus 1. So here you see that we have taken that integration of 1 by this thing with respect to x, that is our I subscript n. That means it is equal to I subscript n. So I subscript n is equal to this thing plus 2n in minus a square this thing divided by x square plus a square whole to the power n plus 1. Now we will take this term to this side. So taking this term to this side, it is equal to minus of 2n a square. Taking this side, it will be plus 2n a square. Plus 2n a square integration of dx divided by x square plus a square whole to the power n plus 1, that is equal to x divided by x square plus a square whole to the power n. So here it is 2n in plus 2n in minus in. That means it is equal to 2n minus 1 whole into in. So we are getting that it is equal to 2n a square is equal to this by this plus 2n minus 1 into in. Now here you see that on replacing so again on replacing n by n minus 1, that means in place of n we will write n minus 1. So on replacing n by n minus 1 we get 2 into n minus 1 a square. Here if you replace n by n minus 1, then it will be equal to n minus 1 plus 1 cancelled out. So this whole to the power n, it is equal to your in. So it is equal to your I subscript n is equal to x divided by x square plus a square whole to the power n minus 1. We are replacing n by n minus 1, so this whole to the power n minus 1 plus, if we replace n by n minus 1, then it will be your it will be your 2 into n minus 1 minus 1, that means it will be equal to 2n minus 3. So it is equal to plus 2n minus 3, 2n minus 3, 2n minus 3, I subscript n minus 1, I subscript n minus 1, because we are replacing n by n minus 1, so that it will be I subscript n minus 1. So from here we can find out that what is the value of In. So In is equal to, I subscript n is equal to 1 by 2 into n minus 1, 2 into n minus 1 a square whole into x by x square plus a square whole to the power n minus 1 plus 2n minus 3 divided by 2n minus 2 into n minus 1 a square into I subscript n minus 1. So this is the reduction formula. This is the reduction formula for integration dx by x square plus x square plus a square whole to the power n. It is the reduction formula. Thank you.